Hi, I'm Stephanie Laser. I'm on the Advertising and Marketing Technology team at AWS. And today we have a very special presentation for you. We're going to talk about sustainability. At AWS, we're committed to sustainability of the cloud and helping our customers with sustainability in the cloud. Today we're going to have Analect and Amazon Ads give a presentation. First up is Rakshit Uppal, who's going to talk about real-time advertising workloads in the cloud.
Thank you, Stephanie, for the intro. I'd like to start with a little story. When I was a little kid, my mom used to always remind me to turn off the lights as I left a room, or to close the back door as I go out to the yard. It was super annoying at the time. But what she was really asking me to do was to be less wasteful. And here I am today to talk to you about how we can reduce waste and be more sustainable. Hi, my name is Rakshit. I am a senior manager at Amazon Ads. I sure hope you're having a good time at re:Invent. Amongst other things, my team owns the sustainability initiative at Amazon Ads. Simply put, we build and drive mechanisms to help tech teams in ads recognize and reduce our impact on the environment. So let's see what we've got in store for you today. We're going to start with a short intro to Amazon Ads. Then we'll cover the shared responsibility model that was just alluded to with AWS. We will then dive right into what Amazon Ads is doing, starting with our industry partnerships. We'll follow this, let me keep moving through. We'll follow this up by our internal strategy, which is 3 simple steps: measure, educate, and reduce. We will discuss more about this as we go through the talk. To wrap things up, we're going to share how ads has innovated in this space and things that we've experimented with, followed by learnings and some takeaways that you can use to make a real impact. So let's get started with the quick overview for Amazon Ads. Amazon Ads reach customers and audiences across Amazon and third-party properties. There's Alexa, Freevee, music, you name it. This next slide provides a view of the various products Amazon Ads has to offer. Each of these products is geared towards our mission, which is to help brands design ad experiences that delight customers and deliver meaningful results. With their insights and reach, they help connect advertisers with the right audiences in the right places, both on and off Amazon. Next, we're going to talk about the advertising lifecycle. We're going to be coming back and referring to this a few times, so let's go slow. To the left, you see 2 personas. There's advertisers, and there's 3P developers, or folks who work with APIs. They integrate with our campaign management systems and APIs to build and manage their campaigns. All of these campaigns then get served via our hyperscale ad server and bidding systems. And from there, while ad serving is happening, we record any clicks, impressions, or views, and we aggregate budget spends in a real-time manner. From there, we then store all of this data in massive data lakes and then use ML techniques to build sophisticated models to improve ad selection and relevance. Final piece is that we return measurement data back to advertisers through our campaign management systems, completing that lifecycle. With that, let me give you an idea of the scale that we operate in. Some of our ad systems manage millions of TPS, process ad requests in low latency situations, operate hundreds of highly available services, and this scale results in tens of billions of impressions worldwide and several petabytes of storage. Today, we will share insights that come from operating at this scale so that you can benefit from it. Before we move any further, let's first level set on terminology. What is sustainability? Sustainability is a discipline that addresses the long-term impact of our activities on the environment. Sustainable development is one that meets the needs of the present without compromising the needs of the future. And the practice of sustainability, and this is what we adopt, is to understand the impact of the energy we consume, measure this across the life cycle, and apply best practices to reduce the impact of their use. So let's go deeper. First up, as was alluded to earlier by Stephanie, there's the shared responsibility model. And that's kind of what surrounds our sustainability sort of framework. There's AWS that is responsible for sustainability of the cloud. And then we can help by using the minimum amount of hardware we need to meet our needs in the cloud. We believe that by working together, we can really scale our impact. Let's talk about what Amazon Ads is doing. We are investing internally as well as externally outside of Amazon. Externally, we recently announced a partnership with ADM302, which is an industry coalition that accounts for more than 40% of world's ad spend through its members. ADM302 is now a signatory to the Climate Pledge, which is a fantastic step forward. Internally at Ads, and this is what I was alluding to when we were going through the agenda, we follow a simple 3-step plan. We had to figure out a way to measure our footprint, then educate our teams, and finally find ways to reduce that footprint. So let's talk about measuring. We identified that our total footprint ultimately consists of 2 things. There's things like building, there's travel, there's scope 3, there's emissions that come from serving ads on 3P websites or third-party websites. And the second bucket that we control more directly is our tech footprint on AWS. Today, we are going to focus on this second bucket. So how did we actually measure our footprint? We did this in correlation to the life cycle we spoke about earlier. We started by identifying all AWS accounts used by Amazon Ads. Any guesses out there how many accounts we might have had? Anybody thinks 500, perhaps? Maybe 1,000? Any guesses at all? We had north of 80,000 accounts. For each AWS account, we were able to get our carbon footprint in the same way that AWS makes it available for all AWS accounts. We then aggregated this data at fleet level or workload level, and there you have it. We got CF per workload or per fleet. Now, these workloads, in our case, map back to the life cycle we discussed earlier, so it was a fairly easy way to aggregate our footprint. What did we find out of that? We found that 4 products, very unsurprisingly, accounted for 99% of our storage, of our carbon footprint. There's the compute side of things, which is Amazon EC2, and other variants of EC2. And then there's storage around S3, EBS, Dynamo, etc. So now that we were getting a better handle on our footprint and where we needed to focus, we moved to the next step. And the next step was to educate. At Amazon, when we want to get our engineers thinking, what do? We run a hackathon. And that's exactly what we did earlier in the year. We got 50-plus teams participating there, and they were fantastic ideas. Here are 2 that I would like to share with you today. At our scale, where we can have hundreds, if not thousands of hosts in any fleet, we have to find an easy way to perform upgrades. And also, that needs to be fully automated. And that's what one of our teams did. So we could then upgrade our fleets iteratively to more newer versions of Graviton or other more efficient instances in an automated and safe manner. The next area was around right-sizing hardware. We had a number of ideas there, but I want to talk to you about one of those. One of our ML teams innovated in that space and showed us that there are some less complex models that do not need to run on the more carbon-intensive GPU instances and perform equally well on CPU-based instances. They ran a POC to show this, and we'll be figuring this out and implementing this down the track. So now that we were learning all these things, how did we make these insights useful? This is the part where we started to focus on reduction. We started with low-hanging fruits, such as avoiding waste, moving to more carbon-efficient instances, followed by workload optimization. We're going to talk through all 3 aspects in the next few slides. Like I told you the story earlier about my mom, this is right here is the same practice applied to our EC2. We started with identifying unused EC2 instances across all of ads. We built a tool that retrieves unused hardware data across all of those 80,000 accounts I mentioned earlier and surfaces on-demand capacity reservations, or ODCRs, that are unused in any given fleet. Now, there are some very valid use cases where you will have some unused hardware, such as when you're preparing to scale, and we do that for Prime Day and other events like that. So perfectly reasonable. But when it starts to go beyond, let's say, 14 days or so, we start to get worried. And we kind of ticket those teams, talk to them, figure out what's the best way to optimize. Since the launch of this, through this dedicated effort that we've driven, there's been meaningful change that has led to us being more frugal. We have driven a 60% reduction on an average in unused hardware in the last 6 months. From the lifecycle we looked at earlier, this ad serving and measurement are two of our largest and most complex set of systems. One such large ad serving system, capable of handling millions of TPS at low latencies, pushed the limits of optimization by migrating their entire EC2 fleet to Graviton in all regions. This gave them a cost benefit of about 35% and reduced carbon emissions by 44%. They went from, I believe, C6Gs. They went to C6Gs from C5s. This reduction has created more headroom for greater innovation for them. There's another large measurement system that moved about 35% of their workloads to Graviton, and that cut their emissions down to in half. We had a very large ad-serving cache fleet that ran a POC to leverage ZSTD compression. Our test results indicated that ZSTD compresses our cache payloads by about 20% on an average. Now, that's what we experienced. We know that this is something that is useful, and results and numbers may vary as you run your own experiments. But what this did was it's going to help us reduce the number of hosts that we need in that cache fleet. There was one thing related to EC2 that you should take away from this session. It is this slide. This is essentially the derivative of what we found over our journey. Now, these, like I said earlier, are our general observations, and results are going to vary based on fleet sizes, workloads, CPU utilization, and a whole bunch of other factors. But that gives you the general idea. As an example, going to R6Gs is going to save you 46% roughly over R5s and 16% over R6Is. Next, let's talk a little bit about storage. In the area of storage, we would like to share two insights. Use S3 intelligent tiering. One of our ad event stores recently moved to S3 intelligent tiering, and they managed to get both cost and carbon reduction. We also built an automated tool that can detect unused data sets that are no longer being queried, and it cleans them up along the same theme of reducing waste. Here's a quick summary of the things that we've done in that space. There's log compression. We spoke about ZSTD. There's lifecycle policies. Use intelligent tiering. You got to set retention policies in S3. Then, along the lines of reducing waste, there's deleting unused and unattached EBS volumes. And finally, one area that we didn't quite go into too much depth earlier on is around using columnar formats like Parquet, which are more storage efficient than other formats. I would like to finally talk about one simple practice that we'd like to encourage within Amazon Ads. Watch your attachments in emails. Use some sort of network storage, perhaps like Work Docs. Imagine if you send one email with a meg attachment out to 100 people, and they proliferate that over to another 100 people. Just think about the data replication that is resulting from that. By simply storing it in one network location, you're going to be saving a lot of space. There's another very simple method, which might sound fairly straightforward, but it helps. Turn off your laptops when they're not in use. Extends your battery life, and also reduces your electricity consumption. These simple things done at scale can have a really large impact. So before I move to the next part, before we move to the next part of the presentation, a quick summary. Focus on reducing waste. Try to adopt more carbon-efficient hardware. And focus on workload optimization. There are plenty of other things you can do. There's, if you're a Java-based shop, JDK 17, and a few other things like that will also help. So with that, thank you all for listening. I would now like to call upon stage John Briscoe from Analect. He's going to share their journey. Thank you, John.
Thank you. Hi, everybody. I'm John Briscoe. I'm the Director of Data and Operations at Analect. I am going to warn you that I'm a fast talker, and I've got 20 minutes and lots of slides. Not lots of slides, lots of content to go through. So I'll be available afterwards in the hallway, or if we have question and answers at the time. I can't speak for Micah, but maybe he'll be there too. He's probably more knowledgeable. So who is Analect? So over a decade ago, Analect was created by Omnicom to reimagine the future of marketing. Now we're a 4,000-strong global specialty services company delivering data-driven capabilities proven to drive better marketing outcomes for our clients. Omni, which is the flagship operating system used by marketers to orchestrate better outcomes, is supported by our data platforms, and it requires more than 8 trillion impressions refreshed daily, over 10 million ad units furnishing capabilities for over 41 markets. All this comes together to drive our need for 51 petabytes of data online at any given time. So I'm just reading through that all. I read through that just so everyone could get an idea of the scale of data we're talking about here. So this particular slide I kept burying because it makes a great like M. Night Shyamalan style twist at the end of, hey, most of this talk is going to be about how to save money, but it also ties in very well with how to save carbon emissions. And so this slide I kept burying because it was like, aha, look, you can save emissions, but really this is the heart and soul of it. So if you take anything away from it, it's this slide. So I tried to put this in order of ability to transform as well as difficulty to implement. And all of these things listed here will come with not only a major carbon emission impact for your organization, but also with a cost savings, which makes it really easy to sell to both the org and to your finance team. So this sets the stage, right? So when you come into this, it's very important, I think, in the cloud, especially when you're talking about complex implementations, such as things that have to deal with carbon emissions, that you are bringing in both the org side and the finance side, along with tech, to walk through what you're trying to do. Because especially when you start talking about at scale, things get really complex, and your ability to blow up the system, which I'll get to in a little bit later, can be very problematic. So having a way to bring the finance team and the org in to say, hey guys, this is why this happened. We knew this was a thing. Here's what we're doing to solve it, et cetera, is very important. For these slides, I'm going to have these faces representing each of the orgs. I tried to get Don Draper because when you think of ad tech, you think of me and Don Draper. But unfortunately, you get me instead. So like many organizations that are starting their cloud journey off, we started off in the cloud, and it's very easy to sell at the time when you're starting off to the finance team, because they're like, what's our startup cost? What's a SAN going to cost us? What's a server? And you're like, nothing. It doesn't cost anything. And they're like, yeah. And they're excited. Then you start doing stuff, and immediately they're upset because you're costing money. So I'm mostly joking about this. It's as long as you're bringing the finance team in with that at the start, they really totally understand what's going on, and they're fairly happy to get how growth is working. So starting off in 2009, we had just the basics. Up through 2014, we were doing just S3 buckets, EC2s, basic RDS. It wasn't even Aurora at the time, and Amazon Redshift. Amazon Redshift was really transformative for our org, and over the next years, this allowed us to evolve a holistic platform for data scientists, and in 2018, start to empower end users with a holistic marketing platform. And all of this comes together to surface that we had really the basics, and we grew exponentially over time just with data and capabilities. And to support this kind of thing, it takes an enormous amount of data. And so what that led to was this, charts. Everybody's excited about charts. So what that led to was these basic services were growing at a scale that was hard to justify to our finance team, right? So we're saying, 15 petabytes of data online, at that scale, S3 is problematic. And so we were really struggling. You can see during the in the bulk of this to both control costs, which also means controlling emissions, and also be able to provide the data we needed to support the platform. Meanwhile, our parent company, Omnicom, starts to make pledges to reduce energy consumption, and all of our clients are becoming more carbon conscious. So it would be nuts for us not to be focusing also on carbon emissions, on top of the fact that we live on the same planet that everybody else does, and so we actually do care, right? Like there's a reason to care, and so that brings a new player into the mix, which is Earth. And so now you're trying to justify to both the org and the finance team what you're doing from a cost perspective, but also from a carbon emissions perspective. And so this is what our original stack looked like. And in the early days of this, we were talking with Amazon about how do we control for emissions, how do we figure out what we're doing, and the response from Amazon was essentially focus on cost reductions. Like Rakshit said, it's turning the light off, turning things off. That reduces your cost, and that ties directly to carbon emissions. And so that made a lot of sense to us. And so it was really easy to sell to the finance team, as we're like, hey, we want to reduce emissions. It's also going to save us a lot of money. And they're like, yeah, okay, you got it, you sold us. So that was what we were doing. This is what the stack looked like. This has continued to grow. Obviously, we didn't stop in 2020. 2020 onto 2023, we rolled out Omni customization, which just required an enormous amount more data. And then into 2023, anybody who's dealing with tech right now knows that there's a significant generative AI explosion, which of course takes GPUs and more compute power and more availability, which is more data and more cost and more emissions. So this has just continued onward, as I think it does for probably most organizations. So the first thing we did was try to tackle this from the point of view of our ad tech. So from the ad tech side of things, we joined with organizations such as Climate Partner, Scope 3, and others to create things like our carbon emissions scenario planner, which we integrated into Omni, our main platform. A scenario planner that enables planners to optimize plans for lower emissions while also considering clients' budgets and performances. It allows teams to compare a previous planned media plan with a sustainable optimized media plan and recommend a media mix shift in favor of sustainability. So that's how we target it that's how we tried to reduce emissions and control for costs from an ad tech point of view. But I work on the tech team, and so this isn't, aside from implementing this stuff, this isn't something I could very well control. So from a tech perspective, we did this, which is lots of arrows. So we moved to on-demand wherever possible and reserved wherever predictable, right? And so when I say on-demand in this case, I'm saying, from our original stack, you'll remember, we had an enormous amount of EC2 was basically our only compute. And so what we did is for EC2, we moved that off to things like Lambda, Fargate, Batch, step functions, et cetera. Also on demand during this time period, Amazon released AWS or Redshift Spectrum, which is the query layer that exists on Redshift. And so that was really transformative to us as well, because we were able to reduce a lot of the size of our Redshift clusters, which reduces cost by a lot, and shift all of that cost over to on-demand query patterns, which it really did change the face of the tech team. So beyond on-demand, the other on-demand is like moving our processes to EMR wherever possible, and Aurora on demand as that came available. There's now also Redshift on demand. I think that was released 2 years ago, and we're working with that too and seeing how that works, and we've had some success there as well. So this was what our original stack looked like, and this is that chart of cost with the bloated middle part. And once we implemented these, we got this, which is a clear trend line of cost reduction, which you'll remember ties to emissions, starting basically in 2020. And I also need to call out during this time that our growth was at the same pace it had always been. Like nothing slowed down. We were growing in both usage patterns and data consumption, right? And so the fact that we were able to consider this in this way was really cool, I thought. And I left this in here so you guys knew this was real data, because it looks better if there's not that spike. But there is a spending anomaly there. So one of the problems with moving to on-demand is you have to be a little bit concerned about usage patterns by data scientists or whoever that might be making use of something, not in a nefarious way, but having a query that doesn't run optimally in Spectrum or whatever that can cause that spike. So that spike's a real spike, and I'm sure I had to answer for that when it came through. But then during this time, Amazon released the AWS Carbon Emission Calculator, which was incredible. So this gave us a real window outside of billing to say, how much is this costing us in emissions? So we started way back when of just saying, okay, cost equals emissions. That's great. Then this came out, and it really transformed the way that we look at all this. So we could stop looking at just cost, and we could say demonstrably, like, this is actually emission data. This is what we're seeing when we make this shift from on-demand or when we reserve. So that gave us charts like this chart, which was proving basically that AWS was right. Control for costs also controls for emissions. So this chart, the orange line is our EC2 emissions in metric tons of carbon emissions, and the other line is basically just redshift. In redshift, you'll remember we reduced the size of our cluster, which is that big spike down by leveraging Spectrum. But we also predominantly could only make use of like reservations, so you don't get the same kind of emissions and cost savings as you would as moving to on-demand things like Lambda and Batch, et cetera. But we did see a pretty big dip, and again, this was with more data and more usage, so incredible. So then we wanted more, right? So now the org is like, hey, we can see this. This is great. And so then we started talking about things that could still save us money, but less money, and have an impact on our carbon emissions. So we started talking about making movements of our EC2 fleet over to the Graviton processors. The Graviton processor is a family of processors designed to deliver the best price performance for your cloud workloads, is what Amazon tells you. And so it also, we tried to implement this across our EC2s. We got a fair ways through it and then realized it wasn't going to work because one of our security agents didn't support ARM-based CPUs, so we had to roll that back. It was a sad day for us all, but that's since been fixed, and we're refocusing on that in 2024. But one thing that you can do that's like totally brainless is just move your Aurora RDS clusters to Graviton. That's literally like a couple of lines of Terraform or a couple clicks in the console, and you have Graviton processors on your Aurora, Postgres, or MySQL, and you're just instantly saving both cost and emissions. So, and that doesn't take any extra know-how really, unless you're doing something really complex probably. But if you were looking closely at the previous slide with all the arrows, there was one place that did not have an arrow, which was S3, which was a major uncovered cost. So anybody who's doing data at scale is going to know that S3 really creeps up on you. You think 0.023 cents per gig, this will never cost me any money, but when you're talking about 15 petabytes, that ends up being a pretty significant sum of money. So this is something that we had to control for still. So this is a chart, this is a real chart of what our costs in S3 looked like. And spoiler, it's on the slide, is we implemented intelligent tiering, which I would recommend everybody does. But the orange slide was our linear growth with S3, and we had this plotted from way before this, and it was right on the linear line, which makes sense because the data we would get was pretty standard, comes through just like we'd expect. And so the yellow line then is what happened when we implemented intelligent tiering. So S3 intelligent tiering, for anybody who doesn't know, is a S3 storage mechanism that moves your data automatically from frequent access to infrequent access at 30 days of untouched to archive tier at 90 days of untouched. And I believe there's 2 more tiers beyond that that are optional that you can move it to. And in those first 3 tiers, if you touch or open a file, it will automatically come back to the standard tier and be fully available. And then it'll start the countdown all over again. So unless you have really random access S3 patterns, this is a no-brainer thing you can implement that will save you costs. And so you can look at this chart here. Again, this is real. We were trending right. Our costs were trending right with the storage line, and then we implemented intelligent tiering. You see the dip. That's the first tier of files being moved off to the 30-day archive, and then you see another enormous dip when things move off to 90-day archive. And so this is a way we could have this data available for anybody that needs it, because it's kind of a choose-your-own-adventure in our environment. You know, the users can use it however they want. But if there's files that aren't accessed that often, they're available and just not costing us any money. So then we ran this up against our carbon emission calculator, and lost our minds. Like that bright yellow line is the S3 carbon emissions cost. So that lines up. You can see that the bright yellow one drops literally off a cliff. Like you can see, like we saw this and our jaws hit the floor because that's a crazy emission savings, and we had a crazy cost savings by doing this. So overlaying these looks like this. The green on the back is the carbon emission savings. You can see that it trends pretty well with, and we only had emissions data back to 2020, unfortunately, because that's when the calculator was implemented. But you can see that we had a pretty clear trend line with what we were doing with cost. So this is the cost overlay with the emissions. So all that to say, you're also not in it alone when you're with Amazon here, right? So we are doing these things to save it, but at the same time, Amazon is becoming more efficient as well. So this is a map. This is, I don't know how, this is probably a few weeks ago, map of Amazon sites and what kind of renewable energy they're making use of. So while you're also making changes to your workloads, Amazon in the back end is also reducing emissions at scale by, putting up solar panels and having wind farms. So one other thing to talk about was those two spikes. I keep going back to the data anomalies because I feel like that's the thing to talk about. So I left these in here, again, real data. What those were is, and this is our emissions, this is our total metric tons of emissions across these sources. Those two spikes were us spinning up infrastructure in AWS regions that were less carbon emission friendly than like US East 1. So we were doing a POC, we spun up some infrastructure, we looked at the emission calculator and we're like, what's this? And so those spikes were our learning that we need to be careful about what regions we're spinning up infrastructure into. So this is something that we now play into whenever we're talking about what to do with our data and where. So where are we now? You can see here 2020, our estimated carbon emissions was 39.1 metric tons of carbon emissions, which is, I tried to equate this over to gas because I feel like people can conceive that better. We started in 2020 at roughly 4,400 gallons of gas used across our cloud. And we've had a 91% reduction of that into 2023 just by implementing what I've just talked about, right? So that was an incredible, so it's essentially taking us from like a full family of 3 American families worth of driving to 1 American person's worth of driving, which was incredible. So back to that original slide. This is stuff that you could take away and do basically right now. So I'm going to go through the biggest hitters. One is obviously move to the cloud. I realized that we're in a 300 level talk at AWS reInvent, and I'm like, hey guys, the cloud's pretty cool. And it's true though, it's really true, and it's something you can do right now with your organization. The more you can move there, there's other things that you gain by this, but also the emissions are huge. And so you get the economy of scale with Amazon, and so I would highly recommend it. The next game changer for us was intelligent tiering. S3 intelligent tiering is almost totally brainless to implement, and the cost and emission savings you saw earlier were demonstrable. So making that change is something you can do unless you have very specific use cases with S3. This is something you could literally go back and do right now and be saving across the board. So incredible. The other stuff here has varying degrees of considerations you have to make when you implement it. But the next two biggest for us was the on-demand where possible, which is the moving of your EC2 fleet to things like Fargate and Lambda. Those can really change the face of your tech org and how you're implementing things and give you a lot of savings. But they are also things that you need to consider more. You can't just move an EC2 to Lambda and call it a day. There's a little bit more to be involved in that. So that's something to get involved with your tech team and your org and your finance team. And then the other huge one for us was number 7, the utilizing Amazon Redshift Spectrum to downsize your data clusters. The example I have for that is we have a number of Redshift data clusters we use very heavily and we love. But at the time we had something like a 55 node DC28XL, which is a very expensive, very awesome Redshift cluster. And because of Spectrum, we were able to tier that down to 20 node, and then later tier that down to an 8 node RA3. And move some of the data onto the Redshift cluster rather than using Spectrum. So we ended up, because of Spectrum and the technology changes with Redshift, we were able to make a lot of new changes that worked to save us a lot of money and to save us a lot of emissions. But then beyond that, then you have now Redshift on demand that is coming up. The other stuff is also very important, but those are ones that change for us. But certainly 1, 2, and 3 will save you a lot, and potentially 4. Thank you for your time. I'm going to hand it over to Micah now, and I'll be available again afterwards for questions if anybody has it. I apologize for the fast speaking.
Thanks, John. Thanks, John. Hi, everyone. How are you today? I can't really see you, but show of hands, if I can, anyone have a chance to get down to the Sphere to see the Darren Aronofsky film? Yeah, a couple of you. I highly recommend it if you have a chance before you go home. It was spectacular. Just a beautiful film, a very immersive experience. But it really got me thinking about how critical this discussion around sustainability is right now. We have to start thinking about how we can embed these discussions in pretty much everything that we do, like every meeting. So yeah, definitely check that out. It's a great film. So hi, I'm Micah Walter. I'm a senior solutions architect at AWS. And I'm what's known as an account SA. So I work with customers directly, like John at Analect, to help them utilize our services in any way that they can kind of imagine. And so I was really excited when John and Analect came to us and started talking about sustainability. One reason was that I realized it was something I didn't know a ton about at the time. And then the other reason was that I just realized how important it was to me, how much of a big concern this is for all of us today. So I saw this opportunity where I could potentially help John and help Analect to kind of start down this journey of sustainability, but also to learn something along the way and hopefully help others, other SAs, other account teams, work with you, the customer, to start your own journey with sustainability. So I'm not going to take up a ton of time. We'll have a little bit of time at the end for Q&A. I just want to give you a few things that you can take home with you when you go back to your organizations, to talking with your leadership, a few best practices that we've learned along the way that John definitely touched on, as well as Rakshit, that you can use to sort of start that journey of sustainability. So we're going to talk a bit about leadership. I'm going to touch on the well-architected framework, something I call pathways towards sustainability. So the different ways you can kind of get started in parallel with one another to start reducing your carbon emissions. And then how do you measure your success? We'll talk a bit about that as well. I think the number one thing we have to really think about is getting our leadership on board. Sustainability is one of those things that requires a culture shift in your organization. It's not something you can kind of just do on your own in your own little pocket of your company. You really need to get the entire organization on board. So to do that, find a champion at your organization who can be that leader to set that North Star for your organization. There's a couple creative ways I've thought about how to do this. One of those is that in many medium to large organizations, you'll find other kinds of sustainability practices already in motion. So whether it's a recycling program or figuring out ways to have a more green space to work in, that kind of thing, these things are probably already going on within your organization. So find those leaders of those initiatives and add your conversation to it. How do we extend this to the cloud as well? Another thing you can do is take a look at the climate pledge. You don't have to sign it today. It's not required. But go on the website, go to the Climate Pledge website and see what other companies have signed, right? See if there's other organizations that are in your same industry or vertical that you can kind of compare yourselves to and use as sort of a source of inspiration. If they're doing it, why can't we? And talk to your account team, talk to us. We at AWS are here to help. So if you have questions, we can find specialists to answer those questions, whether it's having to do with moving to Graviton or understanding the carbon footprint tool. Come talk to us. We'll pull the right people together and help you sort of chart your path. And the other main one, the one that John mentioned quite a bit, is associate sustainability with cost optimization. It's really easy to sell cost optimization to your teams. No one's ever going to say, we don't want to save money today. So start there. Start with how do we save money? How do we optimize around cost? And then add the sustainability aspect to it kind of together. So I mentioned the well-architected framework. Does everybody know what the well-architected framework is? Have you all heard of it? I hope so. It's one of the most important documents that we have on our website. So if you haven't heard of it, after this session, please go to the AWS website and look it up. It's an incredibly powerful document. It's organized into what we call pillars, and one of those pillars has to do with sustainability. So it's a great way to tell yourselves, when you're developing your workloads, are we doing the right things? Are we thinking about all the different aspects around sustainability that we should be? You probably already are doing a few of those types of activities, but there might be areas that you could improve on or that you could kind of balance your attention towards. So definitely take a look at that document. So these are some of the pathways towards sustainability. It's not that you have to do all of these things all at once. It's not that you have to do just one. It's really about finding something that works for you now. So I mentioned building this culture, right? Building a new culture around sustainability. I like to think of it as building a culture of reduce and innovate. These two aspects will really help you kind of build sustainability into the DNA of your organization. So reduction, we talked about it quite a bit already. That's turning the lights off. That's Rakshit's story of closing the door on his way out. So do these kinds of things in the cloud as well. We have lots of tools to help you reduce your AWS footprint. There's AWS Storage Lens. This is a really powerful tool for looking at your footprint across S3. You can use this to find places where you can reduce duplicated data, all sorts of different things that will help you to minimize over resourcing on S3. Right-sizing tools we have to make sure that you're optimized on EC2, turning off EC2 instances when they're not necessary, just the same thing as turning off the light switch. Lifecycle policies for archiving data, using intelligent tiering, that sort of stuff. And schedulers, making sure that you are able to turn down workloads when they're not needed. Maybe it's on the weekends or at nighttime. This is an incredibly powerful tool to help reduce emissions as well. And innovation is really about using the most modern technology. Earlier this week, we had an announcement around Graviton4, and you might have noticed that one of the key aspects that Adam highlighted in that talk was the reduction of carbon emissions with Graviton4. Every time we launch a new version, a new iteration of those processors, it gets better and better. So always think about how do we continually update to the latest technology so that we're taking advantage of what's available to us. So lastly, measuring your success, right? It's really difficult to feel like you're making progress unless you have the tools available to you to track your progress. The carbon footprint tool that John mentioned is in the console now. You can use it today. It's really simple. It has an API as well, so you can download the data and analyze it on your own, but you can also just look right in the console and take a look at where you are. Use that as a baseline. It'll tell you the top spenders for emissions, and you can start focusing on how you can reduce those based on that data. It's also great, like John showed in his charts, to see that data sort of fall off the cliff. So take a look at that. But there's other kinds of activities you might want to think about as well. We have cost optimization workshops available. So if you have an account team, you can start talking to them about doing those. There's ways to do them on your own as well. And these will help reduce your overall spend, but they'll also highlight places where you can think about carbon emission reduction. Kudos dashboards or cloud intelligence dashboards are another thing that you can install in your AWS account. It's relatively simple to do. You can do it on your own through some instructions we have on our website or work with your account team to get that going. And they'll give you all sorts of charts and graphs, all kinds of data, ways to set KPIs, ways to track your progress, both around cost and emissions. And finally, talk to your account team. I think I've said that like 4 times now. Please don't wait to the last minute. Come contact us, talk to us, and we'll help set you on the right path. So thank you all. We have some time for Q&A, but that's it. Thanks for your time.